Hey guys, we're going to be working on a factoring flowchart today, and basically this is a really nice visual way to kind of basically summarize Chapter 8 all on one piece of paper. So in Chapter 8 so far, we're going to kind of go in order through some of the lessons that we've taught, and anytime I've asked you to factor, it'll basically kind of flow through this chart and you'll be able to work through any problem that we've done up until this point, and then also ones on the homework assignment for the next couple days as well. So one of the first questions that you ask yourself when you get to a factoring problem in math is there a GCF? If you say yes, there is a GCF in the problem, then you're going to come over here to this box right here. So this is your yes direction. And if there is a GCF, then you're going to have to factor it out. So I'm going to kind of zoom in on that part right here. And what I want you to write on this box is that you factor out the GCF, if there is one, and then you write the leftovers. That's what I always call them, the leftovers. Inside of parentheses. Okay, so if there's a GCF, we always write the GCF out front, and then you write the leftovers inside of parentheses. So your answer kind of looks like this. You'll have a GCF pulled out front, and then you'll have the leftovers written inside of parentheses, like that. And we'll actually do examples of this as well on the flowchart, so you'll be able to kind of see this done in action as well. Now, if there's not a GCF in a problem, you look at it and you say, nope, there's not a greatest common factor, then you're going to come over this way. And you're going to ask yourself, okay, well then are there 4 terms in the problem? If there are, if there's not a GCF, if there's not a GCF, then you go this way and you ask yourself, are there 4 terms? And obviously there's a yes direction and a no direction. There might be 4 terms, but there might not be. If there are 4 terms, you're going to hop over to this side over here. So this is your yes direction. If there are 4 terms, then you have to do something called factor by grouping. So I want you to underline where it says grouping right here, because that's a specific factoring process. And I'll kind of zoom in on this for you as well. So grouping, what that looks like is there's going to be 4 terms written out. You have to group the first 2 together. So I want you to write group 2, and then you group the other 2 together as well. So I'm going to write group 2 and group 2. You guys always saw me do a bracket around my first 2 terms. So my first group, and then also my other group of 2 as well. Once you group the first 2 and the other 2, then you factor. So right then, factor each group separately. Factor each group separately. And I'll do an example of factor by grouping as well, but that's kind of in words what you're supposed to do. Now, there's not always 4 terms in a problem though. So if there are not 4 terms, then you're going to come down this no direction over here. So write no alongside there. And then you're going to ask yourself, okay, well, if there aren't 4 terms, then are there 3 terms? If there are 3 terms, you kind of have 2 directions that you could go. I'm going to zoom out here a second. You kind of have 2 directions. There's the easy kind with 3 terms. 3 terms are trinomials. There's the easy kind that don't have a number in front of x here. And then there's the hard kind that do have some sort of number. I just wrote a in here. Some sort of number here and here. So if there are 3 terms, you've got like 2 yes directions that you could go here. So I want you to write along this arrow, I want you to write yes, but also it could be a hard one with 3 terms, so this is a yes arrow as well. And then we'll talk about the no direction in a minute. So if you do have 3 terms, it's either the easy kind or the hard kind. So let's just go ahead and write that these are the easy ones and that these are the hard ones, because that's how you hear me refer to them in class. Now, with these, the easy ones, you're always going to look at what your times number is and what your add number is. So if you take a look here, whatever's written last, whatever number's in the C position, that's always your multiply number. Whatever's written here for your B number, that's always your add number. And then you have to think about the question that you're asking yourself in your head is what two numbers, so I want you to write here, what two numbers times to get C, this end number, and also add to get B. Whatever two numbers that works for. So whatever two numbers really do multiply together to get C, and also they add together to get B, that's what you fill in your parentheses with. So your answer will always look like this. You're going to have two sets of blank parentheses. It'll start with X and X, or if you had N's or R's in the problem, you would start with N's and R's instead. And then those two numbers that worked, those go in these positions. And it might be a plus sign here, or it might be a minus sign in there, depending on, whether you had positive or negative B's and C's. So those two numbers, that's what you fill in your parentheses with. So that's what goes here and here. All right, and we'll do an example of an easy one as well. The hard ones are obviously harder, but kind of the visual clues that I gave you guys for the hard ones is you always look at your A number first, and that's your first times number. So I always wrote it like this. This is your first times number. That means that's the first thing that's going to go in the parentheses with the X. So the answer looks really similar to the easy ones. It's still like two sets of parentheses like this, but you've got some number in front of X in that first position. And whatever you multiplied together to get your first A value here, that's what goes in here and here. So if this A value is 2, you might put 2 and 1 here. Okay. If you hop over, after looking at your first times number, then you're going to hop over to this number on the end, and that's your times last number. That means whatever you put in the parentheses here and here, they have to multiply together to get the C number. And then on top of that, when you do your outsides added to your insides, they have to add together to be this B number. So I always write plus O/I for outsides and insides. So this is the trial and error one. Like, you just have to try numbers in that first position, try numbers in that last position, check the outsides and check the insides to see if they really do add up to that B number, and you just try until you get it right. There's not a super fast way to go about that, and we'll do a hard one together in a minute as well. So if those are your two yes options for if there's 3 terms, but there's not always 3 terms in a problem. So, and when I was here with you guys on, let's see, that would have been on Tuesday this week, we talked about, okay, so what if there's not a GCF way up here? What if there's not 4 terms? What if there's not 3 terms? What if there's actually 2 terms? So that comes all the way down to here. So if there's not 3 terms, then let's consider, okay, well then are there 2 terms? That's kind of the question that you ask yourself. If there are 2 terms, then your job is to ask yourself, okay, is it a difference of squares? All right, so I want you to write difference of 2 squares. Now remember, the word difference in math literally means subtraction. So this will look like some sort of perfect square minus another perfect square. Remember, our perfect squares are numbers like 1, 4, 9, 16, 25, 36, and so on. They're that pretty list. All right, but it has to be something that's on the pretty list minus something else that's on the pretty list. And your answer looks really, really similar to the other easy and hard trinomial problems. It's still going to be, when you factor it, it's still going to equal 2 sets of parentheses. But with these ones, it's always going to be the same thing right here and here that you put first. It's just the square root of this first thing. And it's always 1 plus sign and 1 minus sign in the parentheses. And then whatever you have here, you square root that, and that gives you what to put in that second position. We'll do an example of difference of 2 squares to refresh your memory as well. But this is just kind of an overall outline of when you get to a problem that says factor this, what are you supposed to do now that we've learned all of these different methods for factoring? the first thing you ask yourself is there a GCF? If yes, go this route. If there's not, then ask yourself, okay, are there 4 terms? If there are 4 terms, you got to go this route, and you do factor by grouping. But if there's not 4 terms, you come down here, and then you ask yourself the next question. Okay, are there 3 terms? If there is 3 terms, you've got 2 options. It's either the easy kind or the hard kind. If there's not 3 terms, then you come down here and say, okay, well, if there's 2 terms, then is it a difference of squares problem? And if it is, you'll work it out like this, and I'll do an example. Okay? So what we're going to do now is kind of walk through actual examples of problems. So just a second, let me grab my sheet of problems real quick. And I've got some examples to walk through with you. Just a second. Here's the first one that I'm going to give you. So the first problem that I'm going to give you, and I'll zoom in on this, I know it's kind of hard to see, is this problem right here. 3x cubed minus 15x squared minus 2x plus 10. If I gave you this problem as a homework problem, then you would have to start at the top of your flowchart and ask yourself, is there a GCF? And if you look at the problem that I gave you, 3, 15, 2, and 10, there's no number that goes into all 4 of these values. And if I look at the letters as well, I've got x cubed and I have x squared and I have x, but this 10 doesn't have any x's. So they also don't have any letters in common either. So there's no GCF. That means I come down here and ask myself this question right here. Are there 4 terms? Well, this one has 1, 2, 3, 4 terms. It does. So this one has to be done as a factor by grouping problem. So right here, we're going to write that example down. I'm going to switch colors and write the example right here. Please make sure that you're doing the same. All right, so the example was 3x to the third minus 15x squared minus 2x and plus 10. So we know it's factor by grouping because there's 4 terms. That means if we follow the directions right here, we have to group the first 2 together and group the second 2 terms together as well. There is a minus sign in between my 2 little brackets that I drew, so I'm going to drop that down right here as well. And then I start factoring. So just looking at the 3x cubed and the minus 15x squared. 3 and 15, 3 goes into both of those. That's their greatest common factor. And I have x cubed and x squared. That means that they share 2 x's or x squareds. So I would take that out. And then I put my leftovers in parentheses. Well, if I take 3x squared out of this term right here, 3 divided by 3 is just 1, and x cubed, take out an x squared, there's only going to be 1x left. Then I do the next one. Negative 15, I'm taking out 3, factoring out 3, that means dividing by 3. That's going to be negative 5. I had x squared, but I took out x squared, so I don't have any x's left next to this 5. Then I can go ahead and move on to the next group. Let's see, 2 and 10. 2 goes into both of those, so I'm going to take a 2 out. I have x, but I don't have any x's on the 10, so I can't take any letters out. I'm going to go ahead and set up my parentheses, and now I do my leftovers. Now, really, this is a negative 2 being divided by a negative 2. Negative 2 divided by negative 2 is positive 1. I had an x, but I did not take any out, so there's still an x left, so leftover. Then I had 10, and I'm dividing by or factoring out this negative 2. 10 divided by negative 2, that's negative 5. When you do factor by grouping, if you did it correctly, these sets of parentheses right here should match. And because they match, they have it in common, you can factor that out as well. So your next step is to take that x minus 5 that they share out as a greatest common factor. So we just write it one time out front. And then you write the leftovers in the next set of parentheses. So left over, we have this 3x squared and this minus 2. So then in my leftover set of parentheses, I would write 3x squared minus 2, and then that would be my final answer. Okay. Now, the next example that I'm going to give you guys is, let's see here. To write it down real quick. The next example is going to be, all right, take a look at this one. So if this was an example on your homework, we would start at the top of our flowchart and say, okay, is there a GCF? Nothing goes into 1, negative 8, and 15. And letter-wise, 15 doesn't have any letters, so they do not have any in common. Remember, this stands for greatest common factor. They do not have a greatest common factor, so we go down the no arrow here. Then you ask yourself, okay, well then are there 4 terms? No, this one does not have 4 terms. So I go down to my no arrow, and then I ask myself the next question. Okay, well then are there 3 terms? This one does have 3 terms. Now there's 2 directions I could go. I need to know if this is one of the easy kind with 3 terms or one of the hard ones. This one only has an x squared out front. There's no number right here. So this is the easy kind. So then I know to factor it using this method. So go ahead and write the example down under the easy box here. And the example was x squared minus 8x plus 15. And remember, with these easy ones, your job is to start thinking about, okay, I need my multiply number, that's always on the end, that's my 15, and then my add number is negative 8. So I'm trying to think about what 2 numbers will multiply together to be 15, but they have to add together to be negative 8. And I'm going to set up my parentheses here. We're using the letter x in this problem, so I'm going to start them with x and x. So for 15, I know that 3 and 5 multiply together to be 15, but I need them to add together to be negative 8. So if I make these each negative, a negative 3 and a negative 5 is still positive 15. But if I add negative 3 and negative 5, that is negative 8. So then I know that that would work. So I would write a negative 3 or minus 3 and a minus 5 in the parentheses. And remember, I can always FOIL this out if I wanted to. First, this would multiply together to be x squared. Outside would be negative 5x. Inside would be negative 3x, which does combine to be negative 8x. And last, if I times negative 3 times negative 5, I do get a positive 15. So it does check. That means that this is definitely the right answer for that. All right. So we're done with that example as well. Let's see. The next example that I'm going to give you is going to look like this. So 10y cubed plus 20y squared minus 5y. Let's start at the top of our flowchart here. We have to ask ourselves first, is there a GCF? So if you look at the numbers 10, 20, and 5, they do have something in common because 5 goes into all of those. So this is going to go down the yes side of GCF, and this is where I have to factor out the GCF and then write my leftovers in parentheses. So let's go ahead and put the example under this box. And the example that I just had up here was 10y cubed plus 20y squared and minus 5y. So if you take a look, 10, 20, and 5, 5 is the greatest number that goes into all 3 of those, so I would take that out front. You've got to make sure you look at the letters as well. I have y cubed, y squared, and y. In common, they each have at least a y in common, so I'm going to take 5y out. And then my leftovers get put in the parentheses. When I take it out, I'm factoring it out, which means I'm dividing. So 10 divided by 5 would be 2. Y cubed, but I took out a y, so there's going to be y squared left. In the next term, I have 20 being divided by 5. That's going to be positive 4. I had y squared, but I took out y, which leaves me with y. In the last one, I had negative 5 being divided by 5, so that's going to be negative 1. Y, but I took out a y. There's no y's left over then. And that's as far as I would go for a GCF problem. So that would be my answer there. All right, another example. Let's see, we could have this one. So if you had this for a homework problem, 4x squared minus 64, you would look first and see if there was a GCF. Let's see, 4 does go into both of those, but this is a 2-term problem. So I'm going to hop down here and say no for right now. And there are not 4 terms, and there are not 3 terms, but there are 2 terms. And if you look here, I noticed right away with this example that it's a difference problem because there's a subtraction. You can't do this if there's a plus sign in between. 4 is a perfect square, and so is 64. So I can do this problem as a difference of squares. So if we take a look here, let's write the example down that I just showed you, which was 4x squared with a minus 64. In difference of squares, the answer looks a lot like those easy and hard trinomial problems, and except one's always going to be a plus, one's always going to be a minus in the parentheses, and then you just have to square root these. So the square root of 4 is going to be 2. So I'm going to start each of these with 2. And x squared, I have to break that into x and x because x times x is x squared. Then I square root 64. The square root of 64 is 8, and that's what I put in the second position. So what you put first and what you put last in the parentheses will always match. It's just that one parenthesis will have a plus, one will have a minus. That way, if you were to FOIL this out, you would get back the example that we started with. So that would check for you. So there's your answer for a difference of squares problem. And I've got one more that I want to do with you on the flow chart. The last example, I'm sure you can guess what it is, or what kind it is going to be like this. So if I gave you a problem that looked like this, 3x squared plus 10x plus 8, you have to first ask yourself, is there a GCF? 3, 10, and 8, nothing goes into 3, 10, and 8. So I have to go down the no route. If I go down the no route, I ask myself next, are there 4 terms? This one does not have 4 terms, so I would come down the no way. Okay, then are there 3 terms? And this one definitely does have 3 pieces to it, 3 terms. So I just have to decide then, is it the easy kind with 3 terms or the hard? Because there's a number out front of my x squared, this is the hard kind. So we're going to go ahead and write the example down first that I just had on the sticky note, which was 3x squared plus 10x plus 8. And these ones just get tricky. So you got to do lots of trial and error. But whatever I put first in my parentheses have to multiply together to be 3. Whatever I put last in my parentheses have to multiply together to be 8. The nice part is 3 is prime. And if you have a prime number, at the very least, we for sure know what's going to happen first. Because the only thing that multiplies together to be 3x squared is 3x and x. 3x times x is 3x squared. So I can put those in there and kind of lock them in. I'm dealing with all positive values the rest of the way, so I know that it's going to be a plus and a plus. I can kind of lock those in as well. And then I can think about, okay, what times what gives me 8? And let's see, if I think about what times what gives me 8, I know that 1 and 8 multiply together to be 8, and I also know that 2 and 4 multiply together to be 8. And you just pick one and start with it. If I go ahead and put let's see, 4 and 2 in, and then I check, I have to make sure the outsides, when I multiply those, 3x times 2 is 6x. And 4 times x, when I do the insides, that's 4x. If I add 6x's to 4x's, that is my middle 10x right here. So my outsides and my insides did add up to that middle 10x, so that would check right there. Then I can go ahead and say, okay, yep, my first guess just happened to be right for that one. If it wasn't right there, if that didn't check right there, you just keep going. You just keep checking answers. Okay, switch around the 2 and the 4, try 1 and 8 until you get those outsides and insides to add up to what you need them to add up to. All right, so I'm going to zoom out real quick. Your factoring flow chart should be completed with this. There's one little tiny thing that we're going to add on here. And I'm going to make this stand out in a different color. And that's kind of what we're getting into next. So there's not always just one step to these problems. Like it's only one kind of problem. There's also problems where you have to factor completely. Factoring completely means there's probably a GCF first. And once you take the GCF out, whatever's in your leftovers can still be factored. And we'll do some examples like that in just a minute. So I want you to write over here, if there's a GCF, I want you to draw a dotted arrow over here because this doesn't always happen. But after you factor that GCF out, if you can still keep going, you have to then ask yourself, okay, now are there 4 terms? Now are there 3 terms? Now are there 2 terms? And sometimes you can keep going with the problem. These are called factor completely problems. And that's kind of your clue in the problem, that there's more steps than just the one step. Okay, so those are called factoring completely. Your factor flow chart should be done. If there was anything that you visually couldn't see on here, or if you have a struggle with handwriting or whatever, this is posted on Schoology for you guys. So you are more than welcome to grab that off of Schoology and print your own copy if you want to. But yeah, that's on Schoology for you. So go ahead and you guys can start working on your homework. There's going to be another video kind of following up on the factoring completely. So I'll get rolling with that in just a few minutes for you guys. I hope you have a great rest of the day, and I will see you guys when we are back together on Monday.